Hi, welcome back. This is Professor Ridge, and today's lesson on section 3.3, analyzing graphs of quadratic functions. Okay, so we'll start off by graphing quadratic functions of the type f of x equals a parenthesis x minus h close parenthesis squared plus k. Now, we can use our transformations that we studied in section 2.4. So our base graph is the graph y equals x squared, and we know that that's a parabola. So y equals x squared, the squaring function. That's another way we refer to it. We know we got 0, 0, 1, 1, 2, 4. We're just squaring. 3, 9, and then we have an axis symmetry. We know the vertex is equal to 0, 0. There's an axis of symmetry. Which is the line x equals 0, which is the y-axis. So let me graph that. Okay, so we're going to plot 0, 0, 1, 1, and remember the axis symmetry, so do the mirror image, negative 1, 1. 2, 4, mirror image, negative 2, 4, and then that's it. And then again, it's a parabola, so we want to make sure we get that nice curve on the bottom there. So there you go. So that's the base graph, y equals x squared. So now if we want to do f of x equals a x minus h squared plus k, it's going to move our base graph h units horizontally and k units vertically. And then we're going to multiply the y coordinates by the factor a. Okay, so our vertex is going to be hk, axis of symmetry is going to be x equals h. It's always x equals whatever the h coordinate is of the vertex. Goes through the x coordinate of the vertex. And what else do we need to know? And this is the way I think of it. It's going to have the shape of y equals ax squared. So when I do my base graph, 0, 0, 1, 1, 2, 4, 3, 9, 4, 16, so on. Then you're going to multiply the the y coordinate of each point by a. Okay? So it'll be 0, 0, 1, 1a, 2, whatever 4 times a is, 3, whatever 9 times a is, and then 4, 16, then you do 16 times a, so on, just as many points as you need to do. And then of course you got the mirror image on the other side of the axis symmetry. Alright, so let's try one of these and see how we do. Okay, so our vertex is going to be hk, which is 2, negative 3. Notice the h from the formula, in the formula f of x equals a, x minus h, and the vertex is h. So if you notice that the signs are opposites of each other. So here I got x minus 2, so my x coordinate would be 2. And then if you look in the formula, you got plus k, and the vertex is just k, so it's the same sign. So it'll be negative 2, or x minus 2 becomes positive 2, and then the minus 3, so the minus 2 we put in, positive 2, minus 3, you leave it, so you get minus 3. So our vertex is at 2, negative 3, so I'm going to put a dot there. And I also like to think of it as, instead of my translations, right, I'm going to pretend that's the origin. And now I'm going to use my base graph with the a scalar, so in this case it's y equals 2x squared. So again, the base graph is 0, 0, 1, 1, 2, 4, 3, 9. And then you're going to take all the y coordinates and multiply by a, which in this case is 2. So the points that I'm going to plot are 0, 0, 1, 2, 2, 8, 3, 18. Well, I'm not going to plot that one because I don't have enough room on my graph. Okay, so I'm going to do 0, 0. And again, counting from the vertex. All right, or sometimes I call it my pretend origin. Not the real origin, the pretend origin. So 0, 0, 1, 2 will be here. So the real point's 3, negative 1. But again, I'm counting from the vertex, counting from the pretend origin. Do the mirror image. Then I got to do 2, 8. Oh, I need to go out one more. There's 4. So 2, 8. So 2, 1, 2, 3, 4, 5, 6, 7, 8. And then the mirror image. So again, the counting from the vertex, this is 2, 8. But the real point is 4, 4, 5. So basically, if you took 2, 8 and added it to the vertex, so 2, 8, and the vertex is 2, negative 3, if you add 2 plus 2 is 4, and then 8 minus 3 is 5, that's the real point counting from the origin. 4, 5. Okay? And then once I got that done, I'll just graph my parabola. Oops. There we go. So that is done using my transformations. All right, let's put into fx, f of x equals ax minus h squared plus k form by completing the square. All right, so we're going to use the completing square technique so we can find the vertex. Oh, I guess I should write that. Find the vertex. All right, so our first step to do is you just, you want to factor out the a from the first two terms only. So divide both of those by 2. A is 2 in this case. Now we're going to complete the square, so do plus minus blank, plus blank minus blank, and leave the plus 14 out to the side. Now we're going to use that technique of completing the square where you take half the middle term. So 5 divided by 2 is 5 halves. Square it. 5 squared is 25 fourths. Subtract 25 fourths. And let's see, so we get x squared. Now, the first three terms, that's the perfect square, the x minus 5 halves, x minus 5 halves squared. And then you got the minus 25 fourths. And now to simplify this, you got to distribute the 2 with the parentheses. So 2 times x minus 5 halves squared. And then the 2 times the 25 fourths, which is 25 halves, plus 14, which is 28 fourths, or halves, I mean. And then we're going to combine like terms there. So we get 2x minus 5 halves squared minus, or plus, 3 halves. Okay, so vertex is 5 halves. Remember, change the sign of the x, leave the y alone. So it's 5 halves, 3 halves. Now there's a shortcut to find the vertex if it's in this form. And the way you do it is basically, it's kind of like we did with the quadratic formula. We can go through this process and put in A, B, C, and see what the vertex ends up being. And it turns out it's going to be minus b over 2a for your x coordinate, or your h coordinate if it's in the other form. And your y coordinate, well, the easiest way, we can figure out a formula for it, but the easiest way is take whatever your x value is, the minus b over 2a, whatever that number is, and plug it back into the function to see what the y value is. Okay, so in our other form, right, h is going to be the minus b over 2a, and k is going to be the f of minus b over 2a. Alright, so let's try this. Oh, and then the shape of the graph. If I need to graph it, it's going to be y equals ax squared. Axis of symmetry is going to be x equals whatever that x coordinate is, or the h if it's in the other form. Alright, so this is a really important shortcut. Makes life easy for us because completing square can be a little cumbersome at times. Alright, so let's try one using this technique. Okay, so find the vertex A. So we got 4 parts to this question. Find the axisymmetry, determine whether there is a maximum value or minimum value, and state that value, and then graph it. Alright, so our first thing is to figure out what the vertex is. So if the directions were just graph, I have to find the vertex, because that's where I start graphing from. So my vertex is going to be minus b over 2a, comma, f of minus b over 2a. So the h coordinate, if I'm using the other notation, is minus b over 2a. Okay, so minus b over 2a, minus b over 2a. So now a is equal to negative 2, b is equal to 2, and c is equal to 1. So minus b over 2a would be negative 2 over 2 times negative 2. This looks like 1/2. So that's my x coordinate, or h coordinate. Remember, vertex is equal to hk using the standard notation. So if I say x or h, I'm talking about the same thing. Now k, or the y coordinate, the way you find the y coordinate of the vertex is you plug in this 1/2. So you got to do g of 1/2. Okay, so we say g because this function is g, not f. So generally we have f. Plug in negative 1/2, or positive 1/2. Sorry. So 2 times 1/2 plus 1. Punch that in your calculator. So that will be 3/2 or 1.5. So our vertex is 1/2 3/2. And then, so that's A. B, what's the x symmetry? So x symmetry, remember it's x equals h, h being the x coordinate of the vertex. So x equals 1/2. Okay, that's B. C, determine whether there's a minimum value or a maximum value. So before I answer this, just note, I haven't talked about it yet in the lecture notes, is if A is greater than 0, the parabola opens up. And then the vertex is going to give you a max value, not a max value, that's on the bottom, so that would be a min value at vertex. If A is negative, less than 0, then the parabola opens down, so the vertex is going to give you a max value. So it's a max value at the vertex. Now, remember, so the y value is going to be the max value or the minimum value, and the x value is where it happens. Okay, so we're looking for what's the maximum value of the function, what's the highest value, so it's whatever the y coordinate is there at the vertex. Okay, so A is negative, so that means we're going to have a, so here's my answer for C. A is negative, so that's going to be a max value. And it's going to be equal to the y coordinate of the vertex, which is 3/2. Okay. And so now it happens at x equals 1/2. Okay, so the x coordinate's where it happens or when it happens, and the y value is the max value or the min value, whichever case it is. Alright, and then we just need a graph. Okay, so we're going to graph the function, negative 2x squared plus 2x plus 1. So from A we found the vertex is 1/2 3/2. We know the shape is going to be y equals negative 2x squared. It's just ax squared. So I take my base graph, the y equals x squared, 0, 0, 1, 1, 2 squared is 4, 3 squared is 9, so on. And I'm going to multiply all the y coordinates by negative 2. Now if you remember from translations, the negative part flips it over, so that's why it's opening down. And then the times 2 is stretching it, so it's going to make it skinnier. That should be negative 8, and we won't get to negative 18. Okay, so now we're ready to graph. Let me draw my graph. Okay, so we're going to go where vertex is 1/2 3/2. So halfway between 0 and 1, and halfway between 1 and 2. It's right there. Now remember, this is going to be my pretend origin. So I'm going to put in a dotted line just to kind of remind me. Now typically you don't draw this, but I just want to emphasize that's my pretend origin. So counting from there, I'm going to plot 0, 0, 1, negative 2. So 1, negative 2. Now remember, we're at the halfway marks. So there's negative Counting from the pretend origin, there's 1, negative 2, and then the mirror image would be right there. So again, the real point would be 1.5, negative 0.5, but again, I'm counting from the pretend origin. Negative 2, or 2, negative 8. So 2, negative 8. 1, 2, 3, 5, 6, 7, 8. Right here. And then my mirror image is 2 across from there. And then now I'm ready to draw my parabola. Okay, so that's my graph. Negative 2x squared plus 2x plus 1. I want to do one more just to kind of go through this with you again. So let's graph g of x, or let's make this one f of x. F of x equals, hang on. Okay, so let's try this one. 1/3 x squared plus 4/3 x. So that shouldn't be square. So 1/3 x squared plus 4/3 x minus 5/3. So now a is equal to 1/3, b is 4/3, and c is negative 5/3. So our vertex, so that's part A, vertex, is minus b over 2a, f of minus b over 2a. So first we got to find minus b over 2a. That's going to be our h coordinate. Remember, h is the x coordinate of the vertex. So minus b, so it'll be negative 4/3 over 2 times 1/3, which is negative 4/3 over 2/3. So flip it over. So the 3's will cancel, and that'll be negative 2. And then my k coordinate is plug in the answer for that one, negative 2, into the function. So 1/3 times negative 2 squared plus 4/3 times negative 2, that's 5/3. So we punch that in our calculator, and that'd be positive 4. So that's 2 plus a negative 8/3 minus 5/3, which is 13/3. Well, this is 1/3. So we got 4/3 minus 8/3 minus 5/3, which will be, so negative 4, negative 9/3, which is negative 3. Alright, so vertex is negative 2, negative 3. And then our axis symmetry is x equals the h coordinate, which is the x coordinate of the vertex. So x equals negative 2. And then c, let's see, this is positive, so it's opening up. A is positive, so it's opening up. So we're going to have a max value at the vertex, and the maximum value is negative, oh, I'm sorry, it's opening up, so that's a minimum value, and the minimum value would be negative 3. Now let's graph it. Okay, so our shape of our graph is y equals x squared, ax squared, so 1/3 x squared. We take our base graph, 0, 0, 1, 1, 2, 4, 3, 9, 4, 16. So with fractions, I usually go a little bit further because it's being compressed, so I can be able to fit a few more. So 0, 0, still 0, 0. 1, 1 times 1/3, so that's 1, 1/3. 4 times 1/3, 4/3. So we're going to plot point 2, 4/3. Remember, and this is counting from our pretend origin, the vertex. And then 9 divided by 3 is 3. So 3, 3. And then 16/3, which is about 5 1/3, or is 5 1/3. Alright, so our pretend origin is at -2, -3. So I'm going to draw in a dotted line. That's my axis symmetry. X equals -2. So normally you draw that one in. This one, most people wouldn't draw this in, but again, I'm just trying to emphasize vertex is going to be my pretend origin, and I'm counting this, counting from the pretend origin. Now again, if I want to know what the real points are, I just add the vertex -2, -3 to each coordinate. So 0, 0 is really -2, -3. 1, 1/3 is really, you're going to add the -2 to 1, and you're going to add the -3 to 1/3. So the actual point will be -1. Let's see, 3 minus 1/3 would be 2 2/3. So it would be -8/3. Okay, that's the actual point. Actual point, and that's from the pretend origin. Or the vertex, right? So you just add the and you do that for each point if you want to know what the real point is. So -1, 8/3, or I can do, counting from the vertex, 1, 1/3. And you see that's -1, -8/3. And then I got my mirror image. And I'm going to do 2 4/3. So 2 4/3 is 1 1/3. Mirror image. 3 3. Again, counting from the vertex. Do my mirror image. 4 and 5 1/3. So 1 2 3 4 5 1/3. Mirror image, and that's enough. If you want to do one more, you do 5 squared. It's 25 divided by 3, which would be 8 1/3.
Okay, welcome back to this quick lecture. Today's lesson on section.
Alright, let's look at a word problem. So a projectile is launched with an initial velocity of 120 feet per second from a height of 80 feet. The height of the projectile in feet t seconds after it has been launched, is given by the formula S of t equals -16t squared plus 120t plus 80. Determine the maximum height of the object and when it reaches that height. Now if you notice, this is a quadratic formula, right? So we know that the graph of that is going to be a parabola, and it's -16t is A, it opens down. So basically this question is really asking us to find the vertex. So the y value will be the maximum height, and the x value, or in this case the t value, would be the time that happens when it gets there. Okay, so we're just finding the vertex is basically all they're asking for. Okay, so we know it's going to be minus b over 2a. It's going to be -120 over 2a. So 120 divided by 32. 3.75. Okay, that's when it gets the maximum height. And then we're going to plug in 3.75 into the function to find out what the maximum height is. Okay, so that's the second part. And now we want to know what is the max height. Which will be negative 16, 3.75 squared plus 120 times 3.75 plus 80. Now this is a real equation. If you were to shoot something at 120 feet per second for the initial velocity and you're started at a height of 80 feet, this will actually give you, this is an actual real life formula, neglecting any air resistance and, you know, ignoring terminal velocity and all that stuff. But, you know, if it's a rock or, you know, relatively smooth, or a ball bearing or something, it's going to be pretty close to this. Alright, so plug that in your calculator and you should get 305 feet. So the max height's 305 feet and it takes 3.75 seconds to get there. Okay, let's try another one. A rancher needs to enclose 2 adjacent rectangular corrals, one for cattle, one for sheep. The river forms one side of the corrals and 240 yards of fencing is available. What is the largest total area that can be enclosed? So basically we have a river and we want to make these 2 corrals, and we don't care if they're the same size or different sizes, but we're doing it this way. So we're going to let this be x, that distance, and then this distance is going to be y. So our area is equal to x times y in general. Now we want to maximize this. We want to be able to write area as a function of just x only. So we have this constraint of, we have a total fencing of 240 yards. So if you notice, our perimeter, or fencing, is going to be 3x plus y, and that has to equal 240 yards. Okay, so we want to maximize area. This is what we would call an objective function. We're trying to maximize that. That's our objective. So we want to write it as a function with just one variable. So if we can write y in terms of x, then we can rewrite this as a function with just one variable. So from the fencing, we see that y is equal to 240 minus 3x. We do a little algebra and solve that relationship for y. And so now we can write area as a function of x. It's going to be x times y, which is 240 minus 3x. And so now, if I distribute that, and then I'll just rearrange it so it's minus 3x squared plus 240x, you see that that's a parabola that opens downward, so we're going to get a maximum at the vertex. So again, this question is finding the vertex. So the vertex would be minus b over 2a. So remember, this is plus 0, so b is 240 over 2a. It's negative 240. The opposite of b is negative 240. 2a is negative 6. So 240 divided by negative 6 looks like 40. And then, so that, do they ask for the, they want to know what's the maximum area. So they're asking for the k value of the vertex. So this is going to be our maximum. It's going to happen when x is 40. So we're going to plug in 40 into that formula. Negative 3 times 40 squared plus 240 times 40. So that's going to be 4,800, and these were yards, so they'll be square yards. So the maximum area is 480 square yards. Alright, so that concludes the lesson for 3.3. Go to my math lab and complete your exercises there. I'll see you next time.